Hi, welcome back to AT Math. Today, 12.3, Simplifying Rational Expressions. First again, we need to find the excluded values. So take 5 over 8r. Again, I want to make the bottom 0 if I want to find the excluded value. So 8r has to equal 0. Well, if I divide both sides by 8, r equals 0. So in other words, the only value it can't be is 0 because that will make the bottom 0, which means it becomes undefined. You don't want that. Take a look at this one here. 9d plus 1 over d squared minus 2d. Now what you do first is we can divide a d out of this thing. So notice here how they took a d out, leaving d minus 2. Leaves two different options. Because if d is 0, the whole thing becomes 0. And what's the opposite of minus 2 but plus 2? So if the value is either 0 or 2, the whole bottom becomes 0. Now if you don't believe me, you can go ahead and plug in the zeros or the 2, and you'll find the bottom becomes 0 either way. So those are the two excluded values. Now here, x plus 4 over x squared plus 5x plus 6. Notice how they actually split this into two different parts. They split it into two binomials, x plus 3 and x plus 2. The two values you cannot have, therefore, is negative 3 and negative 2. So those are the excluded values. Now you try, go ahead. 12 over t plus 5, what can t not be? Alright, simple enough. I hope you know it was negative 5. Try again. 3b over b squared plus 5b and 3k squared over k squared plus 7k plus 12. Go ahead. Hopefully for the first one you split the b out, so the b comes out and leaves b plus 5. So b could either be 0 or negative 5. And the other one, k squared plus 7k plus 12, you can get k plus 5 and k plus 2. Excuse me, k plus 3 and k plus 4. Sorry about that. And that means your k's can be negative 3 or negative 4. There you have it. Simplify each rational expression if possible, identifying excluded values. Well, 3t cubed over 12t. Notice what they do here. They don't do nothing with the top, but the bottom they split into 3 times 4t. So basically they pull a 3 out. Now why do they pull a 3 out? Because then they can divide the top and bottom by 3. And the t's, well, you have 3 t's versus 1 t, so you just simply take away 1 t from both, leaving t squared on top. That's all you leave on top, though, as notice how the 3 is gone, leaving just a 1. And 1 t squared is the same as saying t squared. So t squared is on top. The 4 alone is in the bottom, so your answer is t squared over 4. But because they said identifying excluded values, go ahead and put semicolon or comma and put t cannot equal 0. Why can t not equal 0? Because if you stick it back into the problem, the over 0 is going to throw it off. I mean, the x equals 0 is going to make this a undefined, which is what you don't want. B, 3x squared minus 9x over x minus 3. First I pull out a 3x, leaving x minus 3. Therefore, that split, and you have x minus 3 in the bottom, so x minus 3 can cancel, leaving 3x. So your answer is actually 3x. However, in that you cannot have x equal positive 3 because that would make this undefined. Finally, c over c plus 5. The only thing c can't be is negative 5. The answer, therefore, is still c over c plus 5. But c cannot equal negative 5. You try, go ahead. 5m squared over 15m. Basically, I can divide 5 from each one here and basically divide 1m out of this one. So divide this by 5, leaves a 3 in the bottom. Divide an m out of this one and take the m away. Leaves m over 3. However, m cannot equal 0. Why, you say? Because if you go all the way back up here, if you have this times 0, it makes the whole thing 0, which is what you don't want. You try again. 6b cubed plus 12b, b squared plus 2, and 3n over n minus 2. Go ahead and find them this time. See how you did. First I can pull out a 6b on top, 6p, excuse me, on top, and p squared plus 2 on the bottom. P squared plus 2 minus 2. So basically the excluded value is going to be a negative number, therefore it's undefined. In other words, there is no number possible to make it excluded. Now what do I go by that again? Let me slow down for a second. I was doing the top when the example is showing the bottom. The bottom saying p squared plus 2. Well, to find the answer for 0, p squared plus 2 is equal 0. So plus 2 minus 2 to both sides. So p squared equals negative 2, root. p equals square root of negative 2, which we know we can't have, so that's undefined, meaning there is no excluded value, so there's no exception. So going back to this again, now I'll pull out the 6p. So we'll pull out the 6p here, leaving p squared plus 2, even though these two cancel, leaving 6p on top. 6p on top, and there is no exception. Why is there no exception? Because I could not make an excluded value. Now over here, 3n over n minus 2, first thing I'm going to do to find the excluded value, instead of minus 2 plus 2. So n equals 2 is the exception. It cannot be a 2. Other than that, this figure I can't reduce at all, so it's going to be 3n over n minus 2, but n cannot equal 2. Now simplify each rational expression if possible. K plus 1 over k squared minus 4k minus 5. This splits into k plus 1 and k minus 5. So once you have k plus 1 and k minus 5, notice how the k plus 1s cross out, leaving 1 over k minus 5. Now notice how they did not ask me to identify excluded values, so you don't have to include them. On your homework, if you do, that's certainly fine. That's not a problem if you do. If you don't, if it doesn't ask for it and you don't put it, that's fine. But to be safe, you might want to put them just in case. Y squared minus 16 over y squared minus 8y plus 16. Well, y squared minus 16 is y plus 4, y minus 4. And y squared minus 8y plus 16 will be y minus 4 and y minus 4, excuse me. Y minus 4 is crossed out, leaving y plus 4 and y minus 4. Again, they did not ask for excluded values, so you don't have to include them. You try, go ahead. R plus 2 over r squared plus 7r plus 10 and b squared minus 25 over b squared plus 10b plus 25. Go ahead at this time. Let's see how you did. R plus 2 over, and this breaks down into r plus 2 and r plus 5. These two cancel out. Now with nothing left, you put a 1 on top. So it's going to be 1 over r plus 5. And here, b squared minus 25 is going to be b plus 5, b minus 5, and b squared plus 10b plus 25 is going to be b plus 5, b plus 5. These cancel, leaving b minus 5, b plus 5. That's the end there. Recall from Chapter 8 that opposite binomials can help you factor polynomials. Recognizing opposite binomials can also help you simplify rational expressions. What they mean is this. You see how the bottom looks almost the same, but it isn't quite? The first thing I would do is swap these around. So I'd put negative x first, like you have here, and positive 3 goes after. But to make it like x minus 3, to change negative x plus 3 into x minus 3, times them all by negative 1, which flips all the signs, allowing you to cancel. So it's 1 over negative 1, which just makes negative 1. You try, go ahead. Okay? See how you did. Hopefully you flip this and then put a negative 1. They do it the longer way. You can, but I wouldn't. Remember, I would just go ahead and make this negative x squared plus 25 and pull a negative 1 out first and get x squared minus 25 and break that up into x plus 5, x minus 5, which gets you down to here. They instead split this into 5 plus x squared and 5 plus x and 5 minus x. You could do that, but again, you're going to eventually take the negative 1 off this thing to make it x minus 5. So either way you get there, either way, you get x minus 5, 2 over negative 1 times 5 plus x. Okay, and that's your answer there. Now if you want to tidy that up and make it negative x minus 5, 2 over negative x minus 5, that's fine. Negative 2 over 5 plus x is fine. And basically, yeah, as long as they total out, I don't care how you solve it. So there's more than one way to approach that problem. Now over here, 2 minus 2m and 2m squared plus 2m minus 4. They pull out a 2 from the top, which makes sense, 1 minus m. They pull out a 2 first here, and you get m plus 2 and m minus 1. Close, but not quite. Take this times negative 1. Actually, take the negative 1 down here, whatever. They take this times negative 1 to flip it to 1 minus m. Cross out, leaves, and divide the 2's out. Nothing on top, so it leaves 1, and then you have negative 1 times m plus 2. I don't care if you have negative 1 over m plus 2 or negative 1 over m plus 2 or 1 over negative m minus 2, all three would be correct. So either way is fine with me. You try again for these three, go ahead. Remember that your way of solving might be different than mine. As long as they total out, it's fine. Go ahead. Alright, let's see how you did. For the first one, 3x minus 12 over 16 minus x squared. First thing I'm going to do is flip this around. I'm going to make it negative 1 over x squared minus 16. Also, I'm going to pull a 3 out of here and make this x minus 4. Well, x squared minus 16 breaks into x minus 4, x plus 4. I see these two, so I'm going to cross out x minus 4, x minus 4. Gives me 3 over negative 1 times x plus 4, which you can make it as, I put it as 3 over negative 1 times x plus 4. You can have negative 3 over x plus 4, negative 3 over x plus 4, whatever combination works for you. Middle one, 6 minus 2x, I'm going to pull out probably a negative 2. Now, you don't have to. I pull out a negative 2 because I want to make it basically by pulling out a negative 2 and flipping these around. See, what I did was I started by putting negative 2 plus x. Plus 6, excuse me. Negative 2x plus 6. I just flipped them around. Then took out negative 2. That way I have a leading x, not a non-x, so I wanted to have an x value in front. Personal preference. Then I'm going to pull out a 2 for each one of these. Leaves x squared minus 2x minus 3. Go ahead and break this down to x minus 3, x plus 1. See, my x minus 3 is going to cancel out, cancel out. Leaves negative 2 on top in 2 times x plus 1. I'll take that. Or you could have, oh, well, the 2's have to cancel, excuse me. So I have negative 1 over x plus 1. You can have negative 1 over x plus 1, or negative 1 over x plus 1, or 1 over negative 1 x plus 1, or 1 over negative x minus 1, whichever way totals out. And the third one, 3x minus 33 over x squared minus 121. Pull out a 3 first. 3 comes out, x minus 11. I put this into x minus 11, x plus 11. X minus 11, x minus 11 total out, leaving 3 on top, x plus 11 on the bottom. That's finished. Biology application. Desert plants must conserve water. Water evaporates from the surface of the plant. The volume determines how much water is in a plant. So the greater the surface area to volume ratio, the less likely a plant is to survive in the desert. A barrel cactus is a desert plant that is close to spherical in shape. What's the surface area to volume ratio of a spherical barrel cactus? For a sphere, S equals 4 pi r squared and V equals 4/3 pi r squared. Basically what we're saying is we're comparing the surface and dividing by the volume. Remember, the surface area, in other words, is what's around the side. It's the container. And the volume is what's inside. So that's why we're taking surface area divided by the volume. Well, they did something a little funky here. They went ahead and just put them together, and they divided out pi. Well, that makes sense. Divide out the pi, and they divide out the r's here. 2 r's versus 3 r's. The bottom wins by 1. Now, here's where it gets a little odd. Basically, what they have left is they have a 4 on top, all right, and they have a 4/3 in the bottom with an r. Now, they're saying multiply the top and bottom by 3/4. Now, why do you do that? Because if you times by 3/4, the top and bottom, this goes on top, and the 3/4 cancels, basically. 3/4 times 4/3, that equals 1. So 4 times 3 is 12, divided by 4 is 3, so 3 remains on top. These cancel on the bottom, leaving just your r. That's why you have 3 over r. They did it a little differently, but whatever. 3 over r. Which barrel cactus has the greater chance of survival in the desert? One with a radius of 4 inches and one with a radius of 7 inches. Explain. Well, they're basically going to take the value they have, which is 3r, and they're basically saying that instead of doing all that, they're just going to plug it in. So the radius of r, radius, which is 4, versus radius, which is 7. Because remember, they already came up with the 3 over r, and the r is simply where it's going to be the different radiuses. So basically you're saying it's going to be a different size. So this is your smaller barrel cactus. I have no idea how to draw a barrel cactus. And this is a larger barrel cactus. And they're asking which one's going to live longer, which one's going to survive better. Well, 3r equals 3/4, 3r equals 3/7. Basically, the barrel cactus with a radius of 7 inches has a greater chance of survival. Its surface area to volume ratio is less than for a cactus area of 4 inches. Basically what they're saying is the larger the barrel bottom is, more water it's going to hold. It's going to be able to survive the dry times better than the smaller cactus. Seems kind of like, duh, the bigger one would survive, but they want math to prove it. So there you have it. And we are done. Thanks again. We'll do some in class. Bye.